thank you for taking all of us to the moon. You literally put all of India on the moon and making us so proud.
It's a good case study for Harvard Business School.
What really was behind the journey and the success of Chandrayaan-3?
The most important thing was there was a big team with a single-minded goal. On any planet or anywhere is one intriguing question we all have.
So can we please get a standing ovation? How many of you remember this face smiling from year to year when Chandrayaan launch happened on your TVs? So can we please get a standing ovation for ISRO and for Nandini?
Thank you, thank you.
Well, I'll start by saying thank you for taking all of us to the moon. You literally put all of India on the moon and making us so proud. And it is always wonderful to talk to you, Nandini. And it is fantastic to talk to you today. So thank you so much. So I'm going to start with a very important question, which I'm sure everyone wants to know. What did that moment feel like?
Yeah. First of all, thank you so much, Devjani ma'am, for inviting me here. I feel really privileged and honored to be here.
It's our privilege.
So, yeah, that moment is something I think none of us can forget. It was one of the most memorable moments we've had. This was something we were anticipating. We knew in the heart of hearts that Chandrayaan-3, the landing would be successful. But you know, having come from a failure and because Chandrayaan-2 we had issues,
Yeah.
It's always tough.
Yeah.
And yeah, when especially the success comes after a failure,
Yeah.
nothing can be sweeter than that. So that moment, we'd all told ourselves like we're not going to be very emotional. Yeah, and but we really couldn't hold ourselves. Everyone was like, people were hugging and some people in tears. And yeah, it was just unbelievable atmosphere in that room that day.
It was unbelievable for all of us. I think even those of us watching in our living rooms, I'm sure there were a few tears, you know, it was just unbelievable. And I remember your face. Remember I sent you the WhatsApp right then. I remember your face and the smile. That's something I will never forget. So we will talk Chandrayaan-3, but before that, I want to start at the very beginning. Let's start with your childhood. And you were an absolutely avid Star Trek fan.
Yeah.
Right? So from Star Trek to ISRO to the Mars mission and then Chandrayaan and now so much more happening. Take us through that journey, Nandini. How did it play out?
So, you know, as a family, we were very fond of Star Trek. And,
as a family?
Yeah,
family.
yeah, the entire family. My father is an engineer and my mother is a mathematics lecturer. So it was always science in the house. But somehow I was just absolutely fascinated by the serial. I think space is something, the word itself, whether it's a wide-eyed child looking at the sky or a very seasoned scientist, it fascinates everyone.
Yeah.
So, you know, to see all the journeys of that capsule going from one place to another, it always tingled the imagination somewhere and it struck a chord. But for us, as I grew up, I don't, I passed out from Delhi University, but it wasn't as if, you know, I was very sure I would get into ISRO. Those days, jobs were hard to come by and ISRO didn't have that many vacancies. But then when I did get into ISRO, I think it was a good opportunity for me. It's been no looking back at all. That was my first job and I've been there 27 years now.
27. In fact, you said ISRO happened to you.
Yeah, ISRO happened to me.
You weren't planning to get in there, it just happened to you.
It just happened.
But when it did happen to you, I'm sure when you joined Nandini, there weren't too many women, whatever research I've done. What did it feel like? I mean, I'm completely, sticking out like a sore thumb.
Yeah.
What did it feel like at that point?
So, especially the group I joined, it didn't have many women because we were into operations, mission operations. And mission operations, and especially when there's a launch, you have to be there at the control center all through. So, not many women wanted to join voluntarily that group. But I was allocated that group, and then I realized this is something extremely exciting. Because why I'm saying that is the universe itself, it holds so many twists and turns. I think that would put any thriller movie to a spot. So, and every time we do something, it kind of challenges your understanding. And then you realize that there's something always is there that you haven't really understood, and you will learn from every mission, in fact. So, I think that part of it, that excitement and the high it gave us, sailed us through. And I did many missions which were interesting. We did this first re-entry mission, and that time I think ISRO wasn't really opening up to media, and I don't know if many people knew. We did this first re-entry capsule. It went to space, stayed there for 13 days, and this module was recovered. It came back to through the atmosphere, survived the heating, and we had our tense moments that time. But then intact, we found the capsule sailing in the sea. So that was a very big event at that point of time, and I happened to lead the operations at that time. So that was one mission, and there were so many other missions, and then came Mangalyaan. So when Mangalyaan came, believe me, none of us had any experience dealing with interplanetary missions. So it was starting from scratch. So went through, and we didn't have much time, we just had 18 months.
18 months.
18 months, because the funding came late, and the Prime Minister announced this project on the Independence Day. And this Mangalyaan missions are interesting because the launch windows come every 18 months.
The launch window
comes?
You had told me something very interesting, which is, by the way, you guys can hear, right? Everyone at the back? Okay. So you had told me something very interesting, which is there's some timing and where everything aligns, where you can talk a bit about that.
So if you have to go in the most fuel efficient way, so that would happen only at one particular moment, wherein the spacecraft has to leave the Earth in a particular direction, and precise to the order of milliseconds, with a certain velocity, and it has to be very, very precise. Like it's like you're targeting an object which is 600 million kilometers away from here. So, so that had to be the precision. So, so all of us went through this grill of going through the literature, and the most important thing, I think, why Mangalyaan was successful was we done our study well, and no country had ever succeeded in the first attempt. So we knew why the others had failed, and we were sure we were not going to make the same mistakes, and we wouldn't repeat any of the mistakes that we had made earlier. And of course, a lot of innovation and technology that went in. So Mangalyaan was
18 months. You had to get down to the precision of milliseconds. 18 months, and then you all work backwards.
So there's this analogy that usually we all give. We like to give this. I'm not sure if you've heard it before. It's like hitting a golf ball from Bangalore to Washington. It has to fall in a bucket which is in Washington. And to make it worse, the bucket is moving.
A golf call from Bangalore to Washington in a specific bucket and a moving bucket. Who wants to take up that challenge? Now, this is the audacity of ISRO that we have all begun to love so much. And, you know, I'm sure Chandrayaan-3, the journey, was as exciting, if not more. Talk a little bit about, you know, what really was behind the journey and the success of Chandrayaan-3. What made it happen?
I think the most important thing was there was a big team with a single-minded goal. I mean, nothing other than, you know, they had to succeed at any cost. And to tell you actually, Chandrayaan-2, we missed by a whisker.
And those hurt more.
Those hurt.
When you miss by a whisker, that hurts.
So, but then, you know, failures are also important because you actually introspect, and though we knew the mistake was small, we found so many other places where we could actually improve. So when the team started working on Chandrayaan-3, they decided that they would not take any chance, you know. And let's say the software part. We had built 2 parts in Chandrayaan-2. You know, you do this, something fails, you go in another path. In Chandrayaan-3, there were 6 parts. So at every instant, if there was a failure, if it's a hardware failure or some sensor doesn't give an update or the engine doesn't give enough throttle, it would take an alternate path. So there were 6 alternate paths, and to tell you, we didn't have to use any of those alternate paths. We came in the first path, the direct path. So that was one part, and they also strengthened all the sensors. Because we took some time to make sure the sensors were more precise, more accurate, and then I already told you about the software, and the legs were made more sturdy. So in the Chandrayaan-2, we could land with the worst case scenario of 1 meter per second. So when the spacecraft is traveling around the moon, it's like something like 1,600 meters per second. That's the velocity it has. So in 20 minutes of time, the engines have to fire and reduce that 1,600 to 0.
In 20 minutes?
In 20 minutes. That's the landing that you saw from the start of landing to the descent. So everything is done by a automatic sequencer. Yeah, we call it as ALS, automatic landing sequence. So there's no ground intervention, and there are a lot of sensors telling you your position and velocity at every instant of time. And if one sensor doesn't work, there are redundant sensors. And if the software takes a path which is unknown, then there is a contingency or a salvage option. And and there are cameras to tell you if you are going to go close to an hazard. So the entire demography, the topography of the landing site was stored in the onboard system, and as it came down, it did a kind of, the cameras were taking pictures and it did a kind of image matching with what it had in store, and then it decided, okay, there's no hazard here, let me just land. So the entire thing was automated and put on board. So this was the landing sequence, and this was made more and more robust. And we had found some, the failure actually helped us to see, you know, maybe even for future missions, to strengthen all these systems, and I think that was a big learning.
There's a classic example of how failure actually builds resiliency, right? It just made you guys stronger to ensure you made it happen no matter what. Very important question, did you sleep that night?
Oh, maybe between 4 to 6, because the rover was coming out of the lander's belly, and the rover came out past midnight, and then we had the first rover movement happening on the lunar surface, and like we were all very excited because, you know, nobody had reached the South Pole and no one knew how the surface was. In fact, we had some surprises too. We expected a lot of dust when it was landing, and we didn't see much dust.
Yeah, you didn't see, in fact I read about that, you didn't see much dust.
You didn't see much dust. So obviously the surface was different from what we thought. And when the rover wheels are made to move on certain surfaces, and then the rover cannot incline too much, and it can take a slope of only say 12 degrees. So we had to be sure we were not moving on a crater or a boulder, and we had to be sure that the rover wouldn't topple. So there were so many firsts happening, and all this were happening throughout the night, because the reason was that we just had 14 days. That is one lunar day. And we had to make utmost of every moment we had with the rover on the moon. So the rover actually got to move 100 meters. It went all around.
That night itself?
No, not that night. I mean, in
Over
those
the
14
time.
days, yeah, over time.
And anything publicly that you can share in terms of any big surprises you all saw?
Yeah, one was this dust, and we also did a hop experiment.
What's that?
The hop experiment was after the end of the lunar day. We gave a small thrust to the lander and made it jump a little bit, so that we could, in future, if we did a sample return, we would gain some experience from this hop experiment. So we made the lander hop a little bit.
Wow.
Went up, and then it also went a little bit, few meters across also. So that was one thing, yeah. There were exciting moments, and especially one of the things, I'm not sure if you read it, we had a payload which was looking at the surface temperature. So there was it would drill a little hole on the moon surface and then measure the temperature profile. And what was really surprising was, within about 10 centimeters, we found a gradient of, the surface was like 65 degrees hot, right, 65 degrees centigrade. And within 10 centimeters, the temperature measured -10.
What? How?
Yeah, so that's how the surface is.
Wow.
So this is one of the findings, and I'm sure there'll be a lot more, because all this data has been collected. There was some seismic activity also measured. We had an instrument, so a lot of things were.
Wow, that's sort of mind-blowing,
yeah,
right? 65 to minus.
Yeah, -10, yeah.
Wow.
So there were lots of instruments, and these instruments have given us precious data, because that region of the moon, the South Pole, no one has ever gone there, and now we will probably know the composition of the soil, and people will try to see if what kind of chemicals. Yeah, there was another payload which again that came public too, that they found sulfur which they did not expect.
Yes, I
so
remember
yeah,
that.
so yeah, all these things are. I mean, all this data is now with the scientists.
Priceless.
Yeah, it's priceless. Yeah.
So Nandini, at any point soon or somewhere in the near future, will ISRO send man or woman to moon?
Oh, okay. Yeah, first I think the target is to send a man around the Earth, like send him to
Around
space.
the Earth.
Yeah, send him to space and get him back safely. That's the first target. So that mission is called Gaganyaan. The astronauts have been identified, they're all getting trained. And in fact, on October 21st, we are doing a crew abort mission.
Wow.
So that mission would go into a suborbital, it will go a few kilometers high, and the system will trigger an abort. Like in case, in the actual mission there's an abort for some reason.
Yeah.
So then this module will come out and then land safely on the sea. And then there'll be parachutes that will be opening, and then it'll float on the sea. So we're doing this test on the 21st of October.
All fingers crossed, I'm sure.
Yeah, this is the first time we're doing this abort test.
All of us will keep fingers crossed for that.
Yeah. So there will be a couple of, after this abort test, I think there'll be a couple of unmanned missions, very similar to the manned flight. And after that is going to be a manned flight.
Wow, we really look forward to that.
Yeah, we're waiting for that too.
And can you talk a little bit about the sun mission? There's been a lot said about that, and there are a lot of questions about that. What is the mission to the sun?
So it's called Aditya. So it's not actually going to the sun. It's just going to 1% of the distance between the Earth and the sun. It's called a Lagrange point. So that point is really special because the gravitational force of the Earth and the sun gets nullified.
Wow.
And it's a stable point. So if a satellite reaches there, it gets into a halo orbit. It's not a closed orbit, it's a halo. So it gets into the halo, but the advantage with that point is it can constantly look at the sun. So it has some very, very precise payloads that has been made by a lot of institutes outside ISRO. And it's going to look at, so all of us are, we read about the solar flares and the coronal mass ejections and the magnetic field that comes out. The sun spews a lot of energy sometimes. And so these flares are also, they affect us in many ways, the weather, especially the satellites. So a lot of people are interested in knowing or studying the corona around the sun. So there's an instrument which will image the sun, that like how we see during the eclipse, the sun disk is covered, in a solar eclipse, and then you see the corona alone. So this instrument is going to be doing that. It's going to block the middle part of the sun, and it is going to look at the corona. Yeah, so its field of view is 1.05 sun radii. So it will look exactly the corona around the sun, and it's going to look at it constantly and look at signals, and there are going to be a lot of scientists who will be analyzing all this data.
Wow. I mean, it's just amazing to hear of the stuff ISRO is working on. And that's something I want to get your perspective on. We keep talking a lot about how innovation is not happening in India because of not enough resources. And here you have ISRO, who is doing some absolutely crazy stuff and attempting first in the world and making it happen with frankly quite limited resources.
Yeah.
So what's your take on innovation? Does innovation need a lot of resources, or does innovation need that mindset and commitment, or is there another answer?
So yeah, in fact, this is one question that a lot of people want to study. Yesterday, if I can tell you, there was a parliamentary delegation, and they posed the same question, and they said, some probably organizations should study how ISRO is doing this. So in fact, somebody was saying that it's a good case study for Harvard Business School to look at how ISRO functions.
Yeah, it's a good case study for our industry.
Yeah, so yeah. So I think it's more about the culture ISRO has imbibed.
Talk a bit about that. What is the culture of ISRO?
So, okay, the one myth about, I think, rocket science is that people think it's only people who are the brainiacs or the geniuses who are working there, but that's not true. I mean, it's not totally true. There are geniuses, but I think it's more about hard work, and you said resilience and perfection.
Perfection.
Yes, these are things which are important, I think, for any space agency, not just ISRO. Talking about ISRO culture, what I've seen is, anyone who's joined ISRO, and if he has an opinion, however young he is or however old he is, he can stand up and speak in a review. And even if it's Chairman ISRO who's chairing that, or a director of a center, he would listen to him. So everybody's opinions matter. And even if, in fact, the navigation guidance and control, that's the entire software which does the landing, that was done by a very young team. Maybe they are in their 30s. So, so anyone who is able to contribute constructively, they are heard, and they can openly speak in reviews, and they can put their proposals forward. Now, coming to, that's one part. I think that's one good thing that I see about ISRO. Coming to the R&D part, I think we are mostly self-sufficient. So the things that we want to do, many times, till now it's been so, a lot of development is done in-house. But now, of course, government, in order to bring in more private players and industries, government has, asked ISRO to handhold, and you will have a lot of so that more people can get involved and we can have more satellites. So the assets we have today is not really sufficient, even though we are doing some very special missions. But if you look at the country's needs today, we just don't have enough satellites. So unless you bring more people together, the private people, the industry, it's not going to happen. So coming back to ISRO culture, I think this is one important thing. ISRO did a lot of things on its own, and the right from the Aryabhatta days, even when we launch a satellite, there's a lot of things we carry over from one satellite to the other. So it's not really that we made a Chandrayaan and Chandrayaan was totally new. There were a lot of things about Chandrayaan which came from mangalyaan.
Yeah.
So the experience actually goes forward.
Yeah.
So that's something I think which works in our favor. And because a lot of it is indigenous, the costs are low.
And one thing you had told me was, it's not just the, whether you're young or old, if you have a good idea, you can contribute. But you had mentioned also that gender never comes in the way,
Yeah.
right, in ISRO?
Yeah.
And I think that inclusive culture also makes a big difference.
Definitely, yeah.
In fact, one thing about Nandini is she never talks about her gender. She's a scientist. Period. It's not a woman scientist, and
Yeah.
I would request this audience, there are no such thing as women leaders and women engineers. We are just leaders and engineers and scientists. You know, that we have to abolish that word.
Yeah,
In fact, one thing we both agree on is, there's this myth, right, that women or girls don't like maths and science. I think she said it somewhere and I loved it, and I cannot agree more with it, is that's a rumor that is being spread by men to keep the narrative, to control the narrative. But coming back to, you talked about partnerships. This morning, in fact, and even here, we had some fantastic startups. We had Agnikol, Galaxy, we had some fabulous startups that are doing such brave work, right, to just disrupt the space tech. So, is ISRO looking at collaborating more with startups, with private industry, and what's your advice to the industry in terms of those who are interested?
Yeah, so now with the new space policy, we have an organization called InSpace. So, so that is led by Dr. Pawan Goenka.
Yes.
So they are going to talk to all the startups, and they're going to help them, and they'll also collaborate with ISRO to see how much of ISRO's facilities can be used by these private players, and how much of ISRO's experience can be shared with them. So we do need young people, we do need all these startups to start building satellites, building rockets. But space is an expensive affair, and failures can really hurt, and especially if it's a private industries, it can really cost you a lot. We've seen that with SpaceX stories many times. We've heard about Elon Musk going bankrupt, but then sticking on, and today we see the difference. So it is not a very easy task. It's something that's going to come with good amount of failures, good amount of tears, and
blood, sweat, tears, everything. Has to go into it. No, and it takes commitment. But I'm sure you have met a lot with these founders. But as I was speaking to, I don't know, the Galaxy people in the room, I was speaking to them earlier, and then of course I know Srinath of Agnikol. That passion, right? That passion that's there in them, that dream to make it happen. I think that just precedes everything else. That commitment.
True.
Right?
True. Absolutely.
Before I open it up to the audience, I'm sure they will want to ask you a few questions. What next? What's the thing you're really looking forward to?
So I think it's the Gaganyaan, the manned mission. and we're all working hard for it, and there are going to be many missions before we actually have man in space. We're going to have very similar missions.
Make it woman in space.
It could be, you know. Yeah, we don't know as of now. So yeah, so that's one big. Then we have, we're dreaming about the space station docking experiments. Maybe next year, government has announced that we'll probably do a docking mission next year.
Next year?
Next year. So that's in an advanced stage. Then they also announced, I saw in the papers on Chandrayaan 4, and there's a mission with, yeah, there was another mission with, where we're collaborating with NASA. I worked on that mission for 11 years. So since I moved to ISRAC, which is the tracking center, I came out of that project because I had to go to this new job. I take up a new assignment. But I'd worked for this mission called NISAR for 11 years, wherein NASA is doing half the satellite and ISRO is doing the other half.
Wow.
So this is having a huge radar, which is like 12 meters. 12 meters is probably a quarter of this room. Yeah. It's a 12-meter antenna with a 9-meter boom.
Wow, that's
huge antenna. So, so it's going to repeatedly look at the Earth's surface and everything about the ecology, the melting glaciers, the rising seawater, the tectonic movements. The scientists are saying that they can predict 4 mm movement in the tectonic plate. So yeah, it can.
That can also, if you track that and to that level, it can also help, I guess, in maybe at some point understanding the trends and what may happen in prediction.
So this particular project is a global one, and there are universities across the world who are going to use this data, and even before the launch they've come up with so many workshops and what they could possibly achieve with the satellite. So yeah, that's another very exciting mission that's going to come up in March. We are in an advanced stage of integration right now.
Who in this room has more fun projects than what she just talked about to look forward to or to work on? So with that, I'll open it up if anyone has any questions. Yes, please, if you can get the mic, please. Just your name and the question.
Hello, ma'am. First of all, congratulations on your Chandrayaan mission.
Thank you.
So I wrote this question for you. What part did project management play in the critical space missions? And followed by, how much technical project manager is relevant in such projects?
Oh, project management, I'm sure you've all seen Muthuvel's and Kalpana's interviews. Yeah. So they were the people doing the project management. They were not the designers, but they play a very key role because they have to integrate everybody's requirement and they have to ensure that you are meeting the deadlines. They are answerable to the management and so on and so forth. That I think project management, at least in ISRO, forms the core in the project team, and they're responsible for everything end to end. And of course, technical, they do need to have technical capabilities because they may not be experts in a particular subsystem. Like they may not be experts in a power system, or they may not be a propulsion system expert, but they definitely need to know a little bit about everything because they are going to make key decisions.
Yes.
Hello. Hello, ma'am. So I have one question where ISRO mentioned we need more and more people like Elon Musk, where private sector can pitch in and help to explore space. So is it not a good idea to provide ISRO's experience to the private sector people who are coming up?
Yeah, I think that's what InSpace is trying to do. Yeah, so the private people actually, InSpace is trying to help the private industries in ways they can, and whatever support private companies require, they're trying to get that from ISRO. I have known of some of these test facilities which are very expensive, so no individual can build it. So those test facilities as of now are being offered to the private industry to test the satellites. So such things are happening, some hand holding is happening.
So for those who don't know, InSpace has actually been built to bridge the gap between private and ISRO. And I think they're doing a pretty good job of building that collaboration further. Right? Yes.
Hello, ma'am. It's very oh, sorry. Are you?
Oh. Okay, you go first and then I'll come back to you.
Thank you.
Yeah?
So, 2
Yeah.
days before Chandrayaan, we had the Russian lunar failure.
Yeah.
How did that impact the morale of the Chandrayaan team?
Oh no, any failure, we feel bad. Like, the space is like there are a lot of things happening in politics, even in sports. But when it comes to space, I think all the countries are friends. And if there's a failure occurring with some other space engineer, we equally feel bad about it. So a loss is a loss.
Yeah, ma'am, it was really inspiring to hear about the mission, and I think that childlike enthusiasm you have was great. I mean, when you spoke about the rover, it was amazing. One question I had was, other than the technical challenges that you faced, is there something like one top or two top challenges that you also faced, other than the engineering?
So yeah, I think in any organization, man management or human management is one big challenge, especially for people who are leading. So you have all kinds of people, and the key thing is to keep everybody involved and keep the morale high in the team. So that's one thing, and it is something that we always work for, and apart from the technical stuff.
Anyone else? Yes, please. Can you get him the mic?
Hello, ma'am. Hello.
Hello.
Okay, let him go first and we'll come back to you.
Okay.
Thank you, madam, for leading inspirational mission, Chandrayaan 3. Just one question. We have a bigger problem, global problem, climate change. Climate change. The World Meteorological Organization, in the sense, they are predicting rainfall variation, drought, flood, and all. You have a IMD in India, in the sense, they are predicting the rainfall in the sense, and also KSMDC in Karnataka, in the sense, they have a rainfall prediction for each Gram Panchayat level. But level of accuracy we have, in the sense, to farmer level or maybe other people, they use the data. In the sense, it is far away from what is really meant for. In the sense, they predict this week it is going to rain heavily. In the sense, the farmer is planning to sow or something, but they could not get rain even a month or even long dry spell. In the sense, how you improve on data? How you improve on data? In the sense, whatever technology you improve upon, so that predictability of the climate data is more accurate and reasonably
So I
cheaper,
got a question.
cheaper
For
the larger people.
So there are two aspects. One is to build sophisticated satellites and then generate good amount of data. Like NISAR is going to generate very good data. The other segment is to build applications. So today the challenge is, okay, we make good satellites, but we need to build good applications. The innovation has to come in the application sector. So people should know how to utilize the data for their own purpose. The modeling, the mathematical modeling or usage of the data, or integrating data from various sources. It doesn't need to be satellite data. It can be a radar data, it could be an in situ measurement, it could be something coming from the database. So all this needs to be integrated and modeled. But I think that is where we need to build more applications for societal purpose. So that is not just the job of ISRO, but universities, people all around
all
need
industry.
to put in, industries, different ministries apart, not just the space industry. All the other ministries need to, the Met department, which is not related to the space department. They're users of satellite data. So, but they don't just use satellite data. They basically use radars, Doppler weather radars for weather prediction. So all these departments also need to work together and come out with more applications which will benefit the society.
Yes.
Hello, ma'am. I'm feeling very lucky to, see you in person. It's like dream come true.
Oh, thank you so much. I feel humbled.
And you're very sweet. I mean, you're always
She is.
smiling. My question to you, I mean, today morning on my phone, I mean, the advertisement flashed like NASA is planning to build house on moon by 2040 or something.
Okay.
I mean, what do you think about it and from
Yeah, so I don't know if you've heard about this Artemis mission. There are 19 countries which are going to participate. So Artemis is basically will go to moon and then it's a sample return, it will come back. So first we need to establish this going to a planet or to moon and come back safely. So that is the first part. And then of course, like all of us read in science fiction, habitation on a distant planet is not really a thing of past. It's going to happen.
Yeah, it is going to happen.
It's going to happen.
Yeah. Yes.
Hello,
Sorry, I'm losing.
I'm here. Hello, ma'am. Satish here. So, even last time when we could not succeed, I was wondering why South Pole. So, it means why not choosing a known place, easy to land. So, what are the motivation to again continue in the South Pole and then?
So the landing issue was not because of the South Pole. So the South Pole is having more craters. If you really look at those pictures, they're there on the ISRO website. It's full of craters and boulders. But we had found a region which was relatively safe for landing. So we were very clear in our mind. The problem that happened in Chandrayaan 2 was nothing to do with the South Pole. It was something to, we had a small software bug and one of the engines performed a little bit beyond its nominal performance. So it's nothing to do with the South Pole, but South Pole is something really challenging because if you have a dispersion in your landing trajectory, there's a possibility of landing in a crater because there are a lot of craters in the South Pole. But the motivation to go to South Pole was since no one had gone there before, there's so many new things in terms of science you can find if you reach the South Pole. So if you look at the map, actually you will see so many other countries are so close to the equator. Nobody's gone further down to that latitude. So obviously the surface, the mineralogy, the composition of the dust and the particles, so anything that we would find would be new. So that was the motivation actually.
I'll take one last question. Yes.
And Hi, I'm Sahil. I'm with Plaksha University. First of all, thank you for being such an inspiration to millions of kids around India who can now dream of space technology. I'm being one of them. The question basically is that since you mentioned Artemis and Gaganyaan both, Artemis or NASA has like 54 years of experience of putting man on the moon, and they have budgets that we can't right now afford in India. So as a team, how do you approach a problem like that when you have very, very limited budgets, very, very limited experience of putting anything in orbit? Because it's obviously something you can't cheap out on because it involves human lives and involves a lot of parameters. So how as a team are you approaching it?
So like I just told you, right, about the Gaganyaan mission. So Gaganyaan mission, we are going to go all out to ensure that the astronaut returns safely. So there's no doubt about that at all. So in terms of, I think, finding resources, this is something we need to do. So we can't be just left behind by saying that we will not send a person in space because it's expensive and, because tomorrow these deep space explorations are going to play a major part. And even in terms of tourism, business, so we won't want to lose out anything. So any of those things. So putting a man in space is just as important for us. And yeah, NASA and I think countries nowadays have realized it's better to work together. A collaborative effort is always better in terms of resources, sharing of technology, sharing of ground resources.
I think she's standing. You have a question? Okay, I'll make that the last question. Go ahead.
Good evening, ma'am. We feel really privileged and ISRO made India proud. Thank you and thanks to ISRO team. So my question is, could you share some of the critical areas where ISRO is contributing in global space research?
Global space research. Yeah, NISR is one thing, NISR which I just mentioned. So it's going to study both the North Pole and the South Pole. how the ice caps are going to melt. And this is one mission that I can think of. There are many other collaborative missions. We are doing one with JAXA, Japanese Space Agency. We're going to do a joint mission to land again on the moon. So the lander would be ours, the rover is theirs, and the launch vehicle is Japanese. So there are plenty of collaborative efforts now coming up. There is Trishna with France, many actually.
Excellent. Okay, if you guys want to stay on, I'm fine. Go ahead. But I do need to let her go at some point. Mike, please.
Good evening, ma'am. My name is Rituparna, and my question to you is, what are the most significant unanswered questions about the universe that you find particularly intriguing, and how might we go about the answering that question?
So, do you think somewhere in the universe somebody is having a summit like this and asking the same question? Yeah, I think finding life on any planet or anywhere is one intriguing question we all have, and we don't have an answer to that.
Yeah. I want to know if ET exists or not.
Yes.
So Nandini, with that, I'm going to ask you one last question before I let you go. All of us have this so-called big dreams, right?
Yeah.
But everything you're working on is so crazily big.
Yeah.
So what is your big dream? What is that one thing you absolutely want to see happen?
So, for most of us, I think more than the personal dreams that we have, it's the national pride. So, we want to make satellites which are really useful to the country, and especially for the defense. Defense. And that would really make a difference somewhere, someday. So that would be my dream.
You already are making a big difference, all of you,
Yeah.
entire ISRO, to the country, to all of us, and to the world. You are such an inspiration, my friend, I can't even tell you. I mean, you're a fantastic inspiration. So keep inspiring all of us and keep making us proud. We're all with you. So thank you so much.
Thank you so much. Thank you so much.
For more content on tech and leadership, subscribe to Nasscom YouTube channel and press the bell icon to never miss an update.